everybody in Israel, and good afternoon, everyone in Rhode Island. We're starting now the second part of our Rhode Island Israel Bluetech startup competition. I would like to say our first session was very successful, and today we have three more companies. First, I want to thank to our committee that organized and worked very hard to get this competition going. Mollie Williams, she's a director of innovation entrepreneurship at Greater Newport Chamber of Commerce. Erin Donovan, who is executive director of Newport Chamber of Commerce, and Vahnish, director of Hub Ashdod. I want to thank again to our sponsors, to the Israeli Consulate to New England, Ambassador Meron Reuven and his staff, to Greater Chamber of Commerce of Newport, and Israeli airline El Al. As a matter of fact, yesterday there was a first, again, historic flight, first from Boston to Tel Aviv, so it makes the distance between Rhode Island and Israel a little bit shorter and easier to get there. I want to thank to our judges, Christian Cohen, Executive Director of 401 TechBridge, Shani Rachamim, Full Stock Engineer at Windward, Mollie McGee, Executive Director of Sanidia, and Ran Sasson, Program Director of CLP Israel, Jay Kogan, President of IYRS, School of Technology and Trade, and Ben Benny, CEO of Dancor. I want to congratulate the three companies that will participate today, and today we'll have only three companies, two from Israel and one from Rhode Island. Kate Logistic from Israel, Jaya Robotics from Newport, and Marine Edge from Israel. Every company will have 10 minutes to present their and then the judges will ask them for 5 minutes. I will try to make sure, and please try to adhere to your time. When you get time to speak, you will be given ability to show your presentation, and when you're done, please stop it so we can continue. The next event will be the ceremony, the final judgment ceremony, where we announce the winner. And I'm pleased to say that the Israeli Consul General will participate. He'll say a few words. That will be on April 12th, noon in Rhode Island and 7 p.m. in Israel. One more announcement before we continue. We got an announcement that Bluetech Early Stage Accelerator 401 TechBridge, Rhode Island, and in collaboration with TechBridge Northeast and Mass Challenge, announced the 2022 Bluetech Startup Early Stage Remote Accelerator. The nice thing about it is that Israeli and foreign companies are invited to participate. So if in the audience we have any Israeli startups that's interested to learn more, please send an email to info@401techbridge.org, info@401techbridge.org. If you have any difficulties, send me information and I will connect you. So with that said, I would like to ask Mollie first to say a few words, and then we'll have Chai, Erin, and then we'll start with the companies. Mollie, please.
Good evening and good afternoon, everybody. Thank you for being here. We're really excited to have our participants pitch their ideas. So good luck to our competitors. Thanks again to our judges who took time out of their day to be judges, and we appreciate your expertise and time. I think that this is so exciting because I'm hoping that this is the first of a long-term relationship between our two countries and cities, and we hope to develop relationships and partnerships, especially for those Israeli companies who would like to enter our market here. We'd love to play a role in connecting you with partners or funding sources or whatever you need. So I hope this is the first of many opportunities for connecting. So thank you for being here.
Thank you, Mollie. Chai, please.
Hey guys, good evening, good morning. Nice to see you all. I'm really excited, and I must say thanks, first of all, to all my partners in Rhode Island and to all the judges who take part in this program. I think in the last session we had a good connection between everybody, so I hope it's going to be the same this day. I'm really excited about the fact that both of the country make this kind of relationship. I wish all the best to all the companies, and good luck to everybody.
Thank you. Hi, Erin.
Good afternoon and good evening. Thank you to everyone participating today. We here at the Greater Newport Chamber of Commerce are just thrilled to further our relationship with Hub Ashdod and of course with Avi at the RIIC. Certainly looking forward to hearing the pitches from you all. Budding entrepreneurs is something that we are committed to helping and assisting with programming, developing partnerships, and assisting you get off the ground to the best ability that we can. So congratulations for making it this far. We look forward to seeing you when you do come stateside in Newport, and we'd be happy to host you here. And I know that you'll be wonderful hosts to our American companies headed your way as well. Welcome and congratulations again.
Thank you, Erin. And now we're going to go to the program. So the first company we'll have is KET Logistic. And Menashe, I believe I gave you already the rights to be a host. So you can share your screen and start your presentation. Yeah, we see your screen. Maybe you want to do it full screen.
It is full screen. Do you see full screen or not?
Perfect. Yeah, perfect. Go ahead. Start with the presentation.
Yeah. So thank you very much for having me here to present. My name is Menashe, and I'm from KET Logistics. We develop energy autonomous IoT kits to smooth supply chains and logistics in general. This would save billions of dollars while reducing carbon footprint and achieve United Nations development goals. So let's start with our team. I'm accompanied by a great team, which each of them have a double-digit experience years in his own field, whether it's physics, mechanical engineering, electrical engineering, or material sciences, as well as software development. I myself have 18 years in the field of emission reduction projects and carbon emissions, with emphasis in implementation new technologies, which are TRL 6 and above, excuse me, in corporations or in infrastructure. I would like to share with you the story how we got to KET Logistics and Bluetech. So the story starts a decade ago when a technology developer approached me with a request to help him to build a framework and funding between water leakages and CO2 reductions. His solution was digitizing water systems with IoT. I must say it was a great success. We implemented thousands of sensors and we achieved water savings and carbon reductions, and it worked great until the battery of the sensors ran out, and the device is as good as its battery. So that's where we started, and that was the first step in the quest of solving IoT and the most basic problem, which is energy. Now, once we found the solution, we approached Mekorot, which is the National Israel Water Company, to join us and develop as a design partner. We have already today a 10-month operating MVP on water pipelines, and we want to adapt the developed, patented, and field-proven technology to smart containers. Basically, we are working with design partners for each segment. We think it's a great win-win for both sides, the cooperation and us as a startup, to reach the market. So let's go to the logistics market. So industry overview as a whole, there are about 12 million containers in the shipping and maritime industry, additional 5 million containers on other transport methods. And
we are not seeing what you're presenting. We only see the PowerPoint.
You only see the first slide?
Yeah, the slides are not progressing.
That's nice. I'm on the fourth slide already.
Yeah, I can follow on the left there. You're okay.
Thank you, Shani.
Let's try to do it again. Yeah, just a sec. And then again.
You can see this. I could see the slides on the left that you were talking to, but you're about to get past our view.
Is it better now?
Yeah,
Yes.
we see the slides that say industry overview and need.
Yeah, so basically, thanks. So this is the first slide. We discussed about the team. We have 3 main members and additional 4 members in the team.
רואים את עמוד מספר 4. תעשה ברודקאסט למצגת. תעשה הצג.
עשיתי הצג.
אוקיי.
Now we see the screen.
כן.
Dream
רואים
team.
את הטים.
אתה על פרזנטרס ויו. תבטל את הפרזנטרס ויו. אתה רואה במסך אחד את הסלייד ומסך אחר את הקובץ.
Can you see that now?
The team, yeah.
Yeah, we see your dream team.
Okay, good. So we'll do it in this mode. I don't know why the presenter is not working. I don't know why. So that's the team. I'm moving on. We got to CAT Logistics. We have an MVP developed on pipelines, and that's the slide that you missed. We have 10 months with results, and we also are discussing with oil and gas companies with our solution. And regarding the maritime industry, there are about 12 million containers, 17 million total globally, and smart containers needs to be on board. Let's say we have several reasons for that. Current solutions for digitization of the segment, it's segmented digitization solution. The need is a full digitization and seamless kit, and that is the solution is with smart containers, and that's what we were aiming at. Value proposition, we can basically link the physical layer with the cloud using our proprietary power and control unit. So who would benefit with that solution? We have multiple stakeholders that can benefit, either in the supply chain efficiency and security, the insurance part, the customs, etc. And the reason that we know there are drivers to do that, because the UN has also already issued some standardization and regulation on that. And I want just to take one sentence of the basic pillars of what he said. Smart container has 3 major pillars. The first one, it's an active smart device. Active means working with energy, and that's what we bring to the table, autonomous IoT capability. So current solutions now are in machine learning vision and does not work well, and the environment needs more sensor-based solutions. The UN document, the same UN document, defined 22 applications and scenario. 90% of them needs sensors, which means they need a battery. So the market is huge, 12 million containers. The needs is there, the drivers are there. There are regulations for that. And what do we actually bring to the table? So basically, we have a non-invasive, self-sustained 20+ years patented solution with management controller and sensors and communication, which are flexible. We can utilize temperature, acoustic, localization, etc., which is needed. We're not invasive to the container, and we can optimize the data load between the IoT devices and the cloud. We aim to raise 2.5 million USD in 2 phases. One is to adapt the hardware, and second is to develop the cloud platform. That would take us about 18 months from investment day, and an additional investment and additional 18 months would allow us to get to a beta testing site and adaptation and miniaturization of our solution. What we're looking for is, except funding, is design partners, NRE mentors, and good people to join our journey. Thank you very much for having me here.
Thank you, Menashe. And the judges, the Rhode Island judges, if you have any question, please start.
I have a question. A couple of slides back, you said something about 20-year operational. What does that refer to?
Well, we developed, let's say, a power panel with a control panel that can basically manage the power supply for the sensor and the communication unit. Now, we are sensor agnostic, and the materials, or it's a solid state physics, much like solar, but not solar, which means the lifetime is about 20+ years. So that's why we meant about 20+ years of operation.
So you're not battery dependent then?
Correct. And
okay.
So we don't need the chemistry, because battery lasts about let's say 3 to 5 years, maybe 7 years, if you're using a solar panel. If you can use a solar panel in that scenario, inside the ship, there's not much light, and there are about 6 hours of light and 16 hours of non-light, which let's say drives you to use a battery. So our solution does not use a battery. It uses our proprietary power solution, and we're sensor agnostic, so we can answer a lot of need in that area.
Hi, this is Mollie McGee. What do you think that a partnership with Rhode Island, with companies in Rhode Island, will bring to your effort?
So if we're talking about logistics, logistics and knowledge on logistics, it's a need that we need to see, not just in Israel, but more in a global way. This is one thing. Second is, let's say, to have a foot in a cozy place in order for us, let's say, to expand there in the US and other operations. And third, of course, I understand that there is also an interest in other application in marine, in any environment, on top and below, and we can discuss that. We did not do that yet.
Thank you.
Can I ask, I apologize, Manish, I'm not sure. So you've developed a control box that is powered for 20 years, so is not battery dependent, and that could interface with any sensor, so temperature, humidity, Bluetooth, Wi-Fi, any wireless technology?
Basically, yes. The answer is yes. The question is, we have a proprietary power panel, let's say, and a control for that. For the control, we can, let's say, connect connectivity devices, sensors, etc. We have to see how many devices are connected in order to have enough, let's say, operational energy for the time that we're discussing. But that's when we are getting into the project, and we define basically, let's say, an energy budget and usage.
Okay. And you quoted some regulatory issues that are coming up with monitoring containers, et cetera. But does that say what to monitor, or yes, meaning yes, the temperature,
that's
humidity?
The 90. So that's what I said. 22 cases were defined by the UN. 90% of them are sensors, and sensor dependent, which means they need power. So we answer about 90% of the cases that they see. Now we have to find out which are the most, let's say, painful for the customer and most profitable for the customer, and pursue that. And that's why we need a design partner from inside the shipping companies.
Oh, I see. Okay. Okay. So you're looking for a design partner in
design partner slash strategic partner slash test bed. I think that's the best way to define the needs and to have a win-win situation between the corporation and the startup.
Got it. Got it. Okay. Sorry if I missed that, but that makes sense. Thank you.
Thank you. Thank you, Menashe, for your presentation. And again, the judges receive a copy so they can later also in their evaluation have more time to see the presentation. We done it with the first phase, and obviously we do it with the second. Now we're going to turn to Gyro Robotics. Ian, you already can share the screen, and please go from here.
Thanks, Avi. Can folks see the screen okay?
Yep.
Okay, great. And I can see you guys. So I guess it's good afternoon now from Rhode Island, and good evening to the folks in Israel. Thanks everybody for joining, especially the judges for making the time. He's busy these days. So Gyro Robotics. We founded Gyro Robotics about a year ago, December 2020, with my co-founder who's behind there working hard while I have this easy job presenting to you guys, Jason Webster. And we are focused on designing, manufacturing, providing high-speed, micro-sized, low-cost, multiple vehicle aquatic data collection drones or robots. What I'd like to do is to share with you why we think this is going to disrupt the market and provide a solution for our customers that they currently don't have today. So the GyroBot system, we've designed this from the ground up to have a micro-sized vehicle that weighs about 6 pounds, can travel at speeds of around 10 knots, and they can work in a pod of between 1 to 20 vehicles that can travel up to 9-10 miles at full speed. And they can dive vertically to 1 to 100 meter depth. So why does this matter? We've seen the unmanned underwater vehicle market threaten to explode for the last 20 years, and it hasn't really exploded. And part of the challenge for customers with these unmanned underwater vehicles is that they tend to be quite large, they're very complex to operate, often dangerous to launch and recover. The mission planning is not straightforward and simple, and they cost a lot of money, anything from hundreds of thousands of dollars up to $12 million a vehicle. And when you lose a $12 million vehicle, a lot of questions can get asked. Our system is priced at $10,000 a vehicle. So if you lose a $10,000 vehicle, it's not quite as eye-watering as losing a several million-dollar vehicle. So what we can do is we can provide data at a scale and at a cost that really is quite unprecedented. And the technology is dual use. So it has applications in the commercial sector, the environmental monitoring sector, for academia, for STEM and STEAM applications, for education uses, but also for defense applications. And I'll cover the markets a little bit later in the presentation. So the GyroBot, we call it a platform, and it's really important that it is a platform, because what we want to be able to do is to create a system that can be very, very simply modified by changing sensors and behaviors for many different types of application. We kind of call it the Swiss Army knife of aquatic data collection tools. Here you see there's 4 examples. The GyroBot Hydro, which is available for production and purchase today, that is a conductivity, temperature, and pressure sensor suite on board the vehicle. It can also collect bathymetric data, so it can create bathymetric maps. When it dives down vertically, you know where it dives down, you know how deep it is when it hits the bottom. And by doing that multiple times with multiple vehicles, you can create a low resolution bathymetric map. It also, when it hits the bottom, we measure the deceleration. So if it's a fast deceleration, then it's going to be hard, like rock. If it's a slow, it's probably a soft bottom, mud or sediment. And it can measure the wave height and the current of the water. That is all able to be done by all the different vehicles. And then when we look at the bio, that's really focused at the water quality testing or the water observing market. It's fitted with the dissolved oxygen sensor, a turbidity sensor. It has temperature and pressure as well. And we're working on with UMass Dartmouth to develop a water collection sample so that you can collect water samples and then bring them back, unclip them from the vehicle and send them to the lab so that you can carry out the different assays with a much more kind of detailed analysis of what's in the water. The Echo, that has got an acoustic monitoring device, and there's lots and lots of applications for that. The offshore renewable folks are interested from a marine mammal monitoring perspective. Fisheries, you can actually figure out what size of fish, what size of shoal of fish is in the water, and it's got aquaculture applications as well. And then the Prime, that is our payload delivery vehicle. So you can actually deliver a payload, and I will leave to your imagination what sort of payloads that could be used to deliver. One of the things that we've kind of really focused on, having the platform that is truly open source software. You can go onto our website and take a look at our GitHub repository. It's very important to us that it's open source software, and it's very important to our customers as well, is that you can very easily change the sensors on board the vehicle. We've got a pretty novel design sensor port configuration. So by modifying the size of the port, you can then put different sensors in for different applications. And as long as the sensor is small enough and the sensor market is moving towards more and more miniaturization, then it really does open up the aperture for the different sorts of sensors that can be added to the vehicle. We have submitted a provisional patent that was filed last February. That provisional patent's filed, and we will look to add more and more features to that patent before we file a full patent about 12 months from now. So here's an example. Good to hear that there's a new service starting up direct from Tel Aviv to Boston. And if you're flying in from Tel Aviv to Boston, you'll fly over this area here, just off Boston Harbor, just near Logan Airport. And in this example, Deer Island, there's a large sewage treatment plant there that deals with all the waste water from Boston. I can imagine a scenario where there's been a hurricane or some other event, and it's caused some leakage from the sewage treatment plant, and you want to find out pretty quickly what the scope of that leakage is. We could launch 20 vehicles, 20 gyrobots from the seaport area, which is marked with the X. They would travel out at a high speed. They would cover off all those different points, do full water column profile dives, collecting data, and come back, and the data is then wirelessly downloaded when they get close enough to Wi-Fi range. That is 1.5 million square meters of water at about 40 feet or 12 meters deep. That equates to 18 million cubic meters. And we could carry out that work in just 25 minutes. A typical unmanned underwater vehicle would take probably in excess of 5 hours to do the same work. Another example, working with the US Geological Survey team, we can do a 2,000 meter river transect. It's important that we know whether there's salt water in the river, where they take the fresh water for drinking water in Philadelphia. We can do that 16 times faster than they currently do, because the logistics involved, we just rock up on the dock, throw the 3 or 4 or 5 vehicles in the water, collect the data. We can do that back in the lab in less than 4 hours. So the markets, we're looking at oceanographic markets, the water observing market, security, and then there's a whole host of emerging markets that are opening up as people talk to us about the different applications that the gyrobots can do. We've got our first sale with an academic customer, a 15 vehicle system. The US Geological Survey folks, we're in conversation with those, multiple Department of Defense agencies, both US Army Corps of Engineers and the Navy, environmental organizations, and Ørsted from the offshore renewable market. So something I'm really proud of, we started our product development March last year. So just about a year ago, we started off the PowerPoint, and we were in the water with our first prototype by September. Jason and myself are the co-founders. We've just hired Sean, who's our technical project manager, and we've got openings for other engineering and business development positions. We've used a contracting team to get where we are to make sure that we keep our costs down. All of these folks are leaders in their fields. Toby Schneider is one of the, if not the best unmanned underwater vehicle software engineer in the world. Ray has been working with us for a number of years on other projects and is a great mechanical designer as well as a product designer. So it not just looks good, it works well as well. Here's a video of the vehicle in the water. I hope it'll play. You never know with these PowerPoint slides. Fortunately, the music stopped. I assume you folks can see this. Okay. It may be a bit grainy. And you can see when this thing is opened up at full throttle, it really kind of travels pretty quickly. This is in water testing in sub-zero conditions of just a couple of weeks ago out in Narragansett Bay. So in summary, oops, one slide too many. So in summary, we went from a concept to an in-water test in just 6 months. We are currently 30% towards our goal of raising 1.25 million by the end of April. And we're in discussion with 3 significant angel groups and actually in due diligence of those groups. The customers are really excited about the low cost, the capability, the modularity of the vehicle, plus the open source software. Going through 2 mass challenge accelerators has been incredibly helpful for us to understand what it takes to be a successful startup. And again, we've got our first order for a 15 vehicle system. And last week, we actually received our first naval order through the Naval Research Labs.
Yeah, I'll have to cut you off. You passed your time, and now the Israeli judges, Shani, Ben, and Ran, please ask your questions.
Let me stop sharing my screen.
Okay, so Ian, I first want to say that this was a great presentation. I really understood where you're going to, and it looks like your team is amazing. I really loved what I saw. I actually have a friend who is a student for marine biology, and she is waiting a year to go out with her specimens to check them. She has to wait so long. So this seems to be like something that can lift us up as a society. Regarding the investigation of undersea water, I wanted to ask if you've considered the possibility of a camera. I didn't notice if you mentioned it.
I'm sorry, Shani. Considered a what?
A camera inside the vehicle.
So a camera. We're actually we've been talking to some folks at the University of Rhode Island, and one of the labs there's got a very small camera. It is an application. It's on our product development roadmap, but right now, in order to establish our initial sales, we're focusing on those 4 vehicle designs.
Sounds great and minimalist. Thanks.
Thank you.
My simple question is how long the energy allows you to devise the bot to stay in the water?
Okay, so Ran, great question. It will go at full throttle for an hour, right? So it'll do about 10 miles doing 10 knots. If you reduce the throttle, it'll increase that by about 30%. And then if you quantify it in terms of dives, it'll do 300 10-meter dives and over 35 100-meter dives. And it'll station keep in one place collecting data for about 24 hours.
And the data is structured, or it's sensor? The data is structured, or is it sensor related? Like you're indifferent for the sensor data or what?
We store all the data in a database and it's exported in whatever format the customer wants, whether it's CSV, HDFI format. Really, it's kind of all user friendly from that perspective. And to change the batteries, I have a vehicle here. People say, how long does it take to charge? Well, we don't worry about charging because we literally twist the vehicle, open up, put 2 new batteries in, which takes about seconds, and then close the vehicle, bang, and it's ready for operation.
My take on this, taking it to open source was brilliant idea.
We're evangelical about that because I see so many issues with customers where they are always fighting with the contractor to get new software this, and it'll cost that much and it'll take that long.
And do you have any questions?
Yes, please. Can you hear me?
Yep.
Good.
Hi,
So Ian, thank you. Hi. I have 2 questions. By the way, we are operating a 10-meter AUV, which weighs 5 tons. So I definitely can understand what you're talking about in the presentation. So 2 questions. One is, what is the first market you are directing yourself? Market or industry? This is one thing. And the other thing is, have you managed to contact research organizations to help you or direct you with the product market fit?
So we've been talking to customers for the last over 3 years. So the technology is driven by customer requirements and needs. The market focus, we actually just changed that because we see academia and research institutions as being a very quick time from interest to procurement. And then they have outreach to local companies and industries, government organizations, and other research and data collection services within their different areas. And there are 33 academic institutions that have oceanographic programs east of the Rockies, right? That's not including the West Coast. So we are focusing on that, but we're also in discussions with the US Navy and the US Army Corps of Engineers, the offshore renewable folks as well. So all the plates are spinning right now.
Thank you, Ian, for your presentation. We'll move now to our third and last company, Marine Edge. And Amichai, you have the full screen. You can share the screen.
Thanks, Avi. Thanks, everyone.
We're going to present it together, Nevel and I. So I will put up the slide, and Nevel, if you can start by presenting ourselves. I will turn up the.
I think
slide.
We are disabled from a. Okay.
Can you see?
Yeah, we see the screen, and welcome, Nevel.
Okay.
Okay.
Hi, nice to meet you all. We are Marine Edge. We focus on marine sustainability for marine transportation, meaning we aim to diminish dramatically the consumption of fuel by cargo ships, and by doing so also to diminish significantly the air pollution caused by ships. We are a team of 3. Actually, Amichai and I, we know each other for over 25 years. We studied together in the Technion in Israel, aerospace engineering. After school, each one of us took his own path. I went to the Navy for 20 years, Amichai went to the Air Force. I started as a chief engineer in the Navy and evolved into chief engineer of the missile ships fleet. After a few years, took more commanding positions. I was a commander of a patrol ship and then a commander of a missile ship. And towards the end of my career, a commander of a larger, more strategic vessel. I retired from the Navy in 2018, and together with Amichai in 2020, we started the Marine Edge. Amichai? You are on mute.
Sorry. Yeah, I got it. So as Nevel said, we know each other for a long time. We're students together for aerospace engineering. I served in the Air Force after that. And then I worked at Rafael, where I started a product line of airborne cooling systems for F-18 and F-16s. After an MBA, I switched into entrepreneurship and started a medtech company that I ran, and another startup in rehabilitation that started off in wheelchairs and then transitioned into auto tech in 2018. It's now in NASDAQ, listed on NASDAQ. It's called RIIC. A little bit about Mark, a third partner. Mark is a software genius with vast experience in all kinds of software, in telemetry, image processing, energy optimization, and all of the things that Motorola ever did. And we have the pleasure of having him on board as our third partner. Nevel?
Okay, so a short overview on the market. The world fleet consists of 90,000 cargo ships, which burn every year about 7 billion barrels of fuel, which is about 1 billion tons of fuel, which is consumed and also burnt and emitted into the atmosphere, together with 3 billion tons of CO2. If we look at the ship fuel economy, then a single cargo ship burns every day between 50 to 100 tons of fuel, which accumulates to about 10,000 tons of fuel every year, costing millions of dollars. And fuel is the greatest expense. Up to 70% of all OPEX is fuel. Next. If we look at the environmental effect, then a single 20,000 container ship, which is the largest container ship in the world, emit like 50 million cars. This is with regard to NOx and SOx. And the largest 20 ships emit like all the cars on Earth. This is why the IMO, which is the International Maritime Organization, have launched several programs to reduce pollution, which is caused by ships. And they are actually requiring ship owners to switch to cleaner fuels, which are much more expensive. And they are requiring manufacturers to improve efficiency of their products. And our solution and our technology can fit both ship owners and manufacturers. Next. Our technology is based on waves. On this slide, you can see that waves persist in 90% of the world, and 90% of the time. Waves in the height of 2 to 4 meters exist in 90% of the world. Our technology, as I said, is based on the waves. As you know, waves, they cause fluctuations in load on the ship and on the ship's propulsion system. These load fluctuations, they cause fluctuations in fuel consumption for the ship, causing the engine to work in a much less efficient manner and to consume much more fuel than it should consume. You can see here on the graphs the difference between a flat sea and the rough sea. The red line resemble a flat sea. And when we have a wavy sea, the consumption increases by as much as 30%, and sometimes even more. What we are doing, we are flattening those load fluctuations and are able to save about 10 to 15% of the fuel consumption. How do we do it? We do it with a mild hybrid regenerative power management system, which you can see here on the diagram below. On the right with the letter M is the main engine, which every ship has. We are hybridizing the ship's propulsion system, and we are adding a shaft generator motor on the shaft, which can act as a generator and also as an electric motor, which can assist the main engine. We are adding an energy pack, which is based on supercapacitors, and we are adding torque meters on the shaft to measure the torques or the loads that are created by the waves on the propulsion system. These torque measurements, they feed our energy management system, which is the brains of our system, which controls the shaft generator motor. Basically, what is happening here is when the loads are low and we have excess of energy, then the shaft generator motor is acting as a generator, sending the excess of energy to be stored in the supercapacitors. And when the load is high, when we are climbing uphill on the wave, then the energy flows back from the supercapacitor to the shaft generator motor, which is now acting as an electric motor assisting the main engine. In this way, we are saving fuel. We implement machine learning algorithms in our energy management system. Basically, we study and analyze the waves, and we are able to predict how is the next wave going to look like, and to intervene with the shaft generator motor in the right and optimal manner. Next slide. With regard to fuel savings, we divided the market into 3 sizes of ships: small, medium, and large. And you can see that we can save between 15% on small ships to 10% in larger ships. You can see the annual savings per ships. And if all ships were installed with our system, you can see the annual savings of the whole world fleet, which is about $70 billion. Advantages: our technology fits any ship size. It works with any type of fuel and in conjunction with any other renewable energy solution like solar energy or sails and so on. No highly personnel is needed because it's all automatic, and we use off-the-shelf components. With regard to roadmap, we are after a tech demo, which we've done last year. In the tech demo, we were able to show that we can save about 10% of fuel. We actually built a hybrid propulsion system of the ship, and we're able to flatten down load fluctuations and to save fuel. Our next stage is to go on board the ship and to install a full system, including shaft generator motor, supercapacitors, and torque meters on a ship. And we are doing this this year. Next slide. You can see the ship on the next slide.
You're coming to your end of the time.
This is the ship we are planning to install on. It's an 8,000-ton bulk carrier called Megan, belonging to an Israeli shipping company called Haifa Marine. And after this year, we have an LOI with EPS. It's a very large shipping company owned by Mr. Idan Ofer, located in Singapore, and we have an LOI stating that we can install on one of their ships once we succeed with the Megan.
Yeah, and it's a 200 ship company, so that means once this goes well, there's a lot of depth for them as a client as well.
Thank you, Nevel, and thank you, Amichai. You passed your time, and the judges, please ask your question.
I have a question regarding how you're using machine learning to calculate the sort of periodicity of the waves. Can you explain how that works and what you're inputting to get those calculations?
Yes, we have, as I mentioned, the torque meters, which are located on the shaft. These torque meters are affected by the waves, and we can actually see a wave-like graph of the torque, and you can measure the period of the wave and the amplitude of the wave, and this way we can intervene with the shaft generator motor in the right in the right manner.
Thank you.
It's important
question.
to say as well that the software can adapt to any size or type of ship. So it's one software that fits itself to any ship it works on. So it is very scalable.
Quick question, what is the approximate cost per system and how extensive is the retrofitting?
Okay, Hi, can you switch to the economic model slide? Okay, here, yes, you can see the annual savings per ship. Underneath it, you can see the cost of the system for the ship owners. It varies between $1 million for a small ship to about $2.5 million for a large ship. We have also a subscription fee, which is a fixed fee. And our revenue is about one third of the price that we are charging the ship owner. And we based our pricing on a 2.5-year ROI, which is it is a good ROI compared to ROIs in this space.
Thank you.
Also,
Sorry, I missed that.
Calculation were based on $430 per ton of fuel, which, as you probably know, is a lot more right now. So even if it comes down a little bit, it will still be much more significant value in a much shorter return time.
Thank you.
I've worked on hybrid automobiles before, so I'm interested from a technical standpoint. But before that, is the Megan, the ship, are they paying you to do the install, or is this kind of a proof of concept and they're letting you install on one ship?
We are partnering with them. We gave them some shares in the company in order to be able to test our system. They believe in the technology. They really believe in the technology. Both owners of the shipping companies are very technical people, and they understand the technology, and this is why they decided to partner with us.
Yeah, so it's still experimental, and we need a platform to experiment on, and they gave us those platforms.
Yeah, I totally makes sense, and I get that's very smart. Does that agreement, though, prohibit you from working with other shipping companies? I would assume not.
No.
Okay.
No limitation at all.
Okay.
So I would like to thank our presenters today. I would like to thank our judges, to the committee. I want to mention the Bird Foundation. As I mentioned before, this is a foundation that gives money to Israeli and Rhode Island and American Rhode Island companies to improve the research up to $1 million. And I have to say, if my memory served me well, Amichai got a Bird Foundation with a company called Softwheel, which apparently, to those who don't know, was connected to Crawford Composite from Rhode Island. So there is a previous connection, and he can be a testimony to the fact that Bird Foundation works. And I encourage all the companies to look at that option. It's an amazing program. So I was very happy that I just happened to remember that. I want to also mention that next week, on the 6th, there will be a presentation for the accelerator startup. So if there is any company that's interested, again, contact 401 Bridge Tech or myself, and we'll connect you so you can listen to it. And it's a really, really good program. And I'm sure that any Israeli or Rhode Island or beyond that will participate will benefit greatly. And then, as I said, final announcement on the winners will be April 12th at noon. And tomorrow or the next couple of days, we'll release first the recording of today to the judges. And then a few days after that, we'll put them public. So hopefully it will help also the companies that presented beyond that just forum, because part of what we want to do is connect you all in a much larger spectrum. And of course, if we can connect Ashdod, Newport, Rhode Island, Israel, that will be a huge benefit. But anytime we can help as part of the program beyond those region, we see it as a success. So again, I want to thank everyone that participated today. Good afternoon to the one in Rhode Island. You still have to work some. Good night to the one in Israel. And looking forward to see you all on April 12 at noon for the award ceremony. Thank you again to everyone, and good night.